We're going to use this example as a way to demonstrate the concept of recycle in a chemical process, in this case a chemical reaction. So let me pause, draw a diagram that represents this process, and then let's discuss the individual flow streams. So in this system we have a feed rate of 100 kilomoles of A into our system, and then we mix this with a recycle stream. We have this reaction, A goes to B. What we're going to do is separate out all the B here, so this recycle stream only contains A. So the flow rate here of A is 100 plus whatever the flow rate in that recycle stream is. Now the wording in the problem says 60% of A that enters the reactor reacts. So that means the flow rate of A leaving is 40% of what enters. 60% reacts to form B, rest leaves. The problem further says that we're going to remove B in the separator, but we're also going to remove 20% of the A that's in the stream. So 20% of 0.4 times 100 plus R. And that means the recycle is the remaining 80%. And so the question is, how many kilomoles per hour of A enter reactor? So keep in mind all these numbers that I've written down are kilomoles per hour. Well, this is the recycle stream. So 0.8 times 0.4 times 100 plus R is equal to R, which means we can solve for R. So I've just rearranged the equation, which means if we solve for R, we get a value of 47.06, which in terms of significant figures, problem, this would be 47 kilomoles per hour in the recycle stream. So we feed 100 kilomoles per hour and we add an additional recycle of 47, so that we're losing some A that's not reacted in this stream mixed with B, and we're removing all the B that formed due to the reaction.